Well, hi. So I'm recording a prologue here to the video you're about to watch. I do these things live and I don't really know what to expect when I get into a video. And generally speaking though, I get through some kind of repair and a chance to try the radio's operation. This video that's coming, you're going to hear me ruminate through the whole thing. Just ruminate about the wires, the cracked wires that are in here, and a couple other discoveries that I'm going to make along the way. So watch this video if you dare. It's just me talking and rambling on about the wires. Or don't watch it. That's your choice. Thanks a lot. Here comes the video. Well, hi, good morning. Thank you so much for coming and joining me in my shop here for a little more work on this radio. So what I am going to do, something I have been avoiding right up until now, is I'm going to look at all those cracked wires inside this radio and replace those that are worthy of replacement. And I don't know how many that might be. Looked like 5 or 6, but I did not study the situation very carefully. So that's what's happening here. So I'm taking the bottom plate off to get access to those wires and start replacing them. I think step one is to take a bit of an inventory here and just see what I'm into. So pretty obviously all the yellow wires are cracked. So there's one here running. It's going to be hard to see on the camera, but let me get a more ideal pointer here. Here we go. So this yellow wire comes around here and it disappears into a black cover. The black cover, it has, you can see it come all the way down here. Now that yellow wire is coming out here and traveling along through here, all the way down, all the way somewhere down, right down into here. So just this first wire alone runs all the way from here to here, and inside this cover there are a couple other wires. There's a red one here and a black one here. Look at this end, we can see the black one coming out. See the red one coming out. Goes all the way to here, right to the high voltage terminal here. Didn't I cut those free? I left this one on. I thought I cut them all. I thought only one of them had to be cut. This one's still connected to the original capacitor. Okay, not to get too sidetracked now. So to do that yellow wire, the only thing I can do is replace not only the yellow wire but the red wire and the black wire and try to duplicate this arrangement all the way down here. So I also noticing the red wires are also breaking here, or the covering is breaking off of them. So here's a red wire here with some exposed conductor. So to a large degree, probably just looking in this area, 50% of the wires here have to go. Now there's black ones here they have a heavy coating on them. That looks like something that was slipped on over the wire. There's a red one here. You can see the cracks. I can see anyway the crack running along the top of the plastic where it's split. It's splitting a bit. It's become hard and cracked. So here's a twisted wire here. Probably two black twisted wires. Probably going to heaters, but I'm not sure what they're doing. Looks like it's cracked right there. Here Down here is a black wire, and you can see the insulation has come off it, and it's almost in contact. Wow, it's really close to shorting against here. So there's another black wire. The insulation, look at the insulation is just coming on right off. This one's kind of airborne, so it doesn't really matter too much. Like it can't short to anything. Look down here. Here's a black wire. So this wire and this wire, it's very hard to see, I'm sure, because everything's black, but they are traveling together inside this. This is going up. This is the feed to the light bulbs on the front of the radio, the panel lights. So this should probably be replaced, just like I did part of the other wire. It's cracked right in here. So these cloth covered wires, they're a little flexible and they look okay. There's a, what is this? Is it taped? So this wire comes up here and it's taped. There's a loop and it's taped and it's just hanging in here. This is very suspicious. I saw something on the schematic that looked just like this wire. It's just a wire coming up here going nowhere. So there's a chance this is a capacitor, although it's not the way they normally are done. I don't know what this is. Okay, so there's a ground terminal here with a heavy wire on it, nothing connected to it. I don't remember anything about that. And in this wire, there's a piece sticking. No, you know what? It was a piece of solder just laying on it or something. I thought it was a piece of conductor sticking out. It's not. This end of the radio's not got a lot of wires that are cracked. Well, I'll take that back. So here's one of these yellow ones here. This is the terminal that I cut away from here. So there's a red one here. It's all cracked. This one here too is all cracked. So we got black wires, yellow wires, and red wires that are cracked. That's just about all of them. It's like just about any wire that isn't a cloth covered wire has gone cracked in here. It's worse than I thought, because I say I've been kind of ignoring this problem, hoping it just would never manifest itself, and it never did. There's no evidence that any of these cracked wires is causing a problem right now. But, you know, we put this in a car and bounce it for 40 miles. You can't be sure what has happened underneath. That's what's going to happen. I don't think it's 40 miles away, but it's going to travel in a car. What about all these up in here? These all look fine. They look like they're probably bare wires with a cover slipped on them, and the cover is heavy duty. They're all fine. There's some braid here. There's some braid up in there. Oh my gosh, there's another capacitor. I missed one. Right up under here. Oh my gosh. It's soldered to the chassis here. It's sitting right here. Oh boy, I got a lot of stuff to think about here before taking any action. You know, here's another one I left in. I left this one in. Thought I was done. Well, you're never done till the radio actually leaves the house. So quite often after I shoot videos and it's all finished and the last video's gone up, I then realize things that I maybe forgot to do or didn't do or whatever it might be, and I just go ahead and take care of that stuff, and it never appears on video. Minor things that you might forget about. Okay. There's an awful lot of work in here, and see this wire looks, it's all cracked in here, and then where it's bent, the insulation's come right off. This wire it looks like it's going through a hole. I don't know, I think it's way down under here somewhere. Wow, so this is a disaster for me waiting to happen, no doubt about it. The number of radios where I've done this kind of work is absolutely zero. Other than one or two wires here or there, I have never actually gone after the wires in a radio like this, which is part of the reason why I was trying to avoid it. I got to stop and think about this a little bit. To me, my risk antennas are just going like crazy right now. Maybe there's some of these that can be done that are at risk of things going wrong, but at the same time aren't so risky to work on. Like an airborne wire doesn't really matter, but one that's up against the chassis or crossing other wires, that one would matter more. Or maybe one that's tucked inside this protective thing. Two things could happen in here. They're protected, so it could be the wires are in good shape inside here, even though they're cracked outside. Or the opposite could be true. They could be just so frail in here that the slightest movement of this black thing, and boom, they're all shorted together inside there. Oh my. Oh boy, oh boy. I really underestimated this also. I thought this would be just a couple hours of work. Take a couple hours just looking at it and making sure you don't get into trouble. My voice is weakening as I shrink away here. I'm going to go hide in my coffee cup for a bit. I've been in here for 15 minutes staring at this radio, and the coffee did not help very much. The more I stare at it, the more cracked wires I see, and the more anxious I am about working on this. So if we can kind of divide the radio into two parts, this part and this part. This part wouldn't be too tough. There aren't a lot of wires, and they're all kind of out in the open. And I can see both ends of most of the terminals. Maybe I should take that back. There's quite a bit up in here, which I wasn't looking at when I'm looking at it this way. In this part, just about every wire you can see has to go. Now there are some that are in these heavy covers, which I think are fine. But there's no cloth covered ones, or very few cloth covered wires down in here. And in some cases, what's happening right here? Oh, there's a connection. Maybe there's a terminal buried under here. A capacitor. Here, it must be a splice in here, and they've taped it again, so that's just an odd thing to do. This is odd. This feels like vinyl electrical tape, so this might be, somebody else may have done this. This is going right to the antenna connection. This is the incoming antenna wire through the capacitor onto this wire, which is cracked, and then all the way up goes under this metal panel, goes into a sleeve, a yellow sleeve of some sort, and from there, I think it might be a resistor connected and the wire, and they're connected together right down in the bottom there. Oh boy. Oh my gosh. This is just thinking about repairing it is scary enough, but actually just the condition this is in, it's really, really on the edge. Another approach would be to try to safe up every wire. Maybe that's a better approach. Right? Look at the locations where these wires are and where they are at risk of shorting. Tape them up, cover them, space them out, or replace them if that's what makes sense. That's probably a much better way to go, come to think of it. What I'm panicking about here is I'll start doing this and I'll make 2 or 3 mistakes, and good grief, trying to find those mistakes and then having to go through the problem of correcting it. Here's a good example of safing up. Let me switch to the close-up camera here. I'm feeling a little better suddenly because so what did I see? I saw, so like right there, where, that's not the one that I saw though. So look here, look at that. So we've got a cracked wire pushing up against another cracked wire. So that's the kind of thing where I would say, okay, either we got to replace one of these 2 wires, the green one. Oh my gosh. Or bend these into a safe position. Of course, the moment I bend these wires, what's left of the insulation is going to flake right off. Well, that could be, step 1, try to space them. Step 2, try to, what did the owner do? He put tape on cracked wires. I might end up doing something similar here. You could sleeve some of these wires, but that's a difficult undertaking. You can't use a split sleeve. I don't have split sleeves, so you'd have to cut one end of the wire and then, slide the cover up to the area where you want it. In the course of doing that, all kinds of insulation is going to fall off these wires. There's another spot where you've got yellow wire and the red wire. I'd have to assume they should not contact each other, but they're on their way right in there. But you see a little bend. Yeah, a little bend, and what's left of this yellow insulation is coming off. This is just looking worse and worse and worse. I have such mixed feelings about this. This is way more work than I thought. Because, as I said, I was trying to ignore it. Ignoring it was a good policy. That was a good policy. Look at that. Black wire down at the bottom there. You gotta kind of wonder what's happened to this particular radio. I mean, it could be that every radio of this type, this exact model, looks like this inside. If there are any others of these. That's a connection point. So let's look at this situation here with this black sleeve. So the end of the black sleeve, it's under everything. See, the yellow and the red wires are disappearing into a black sleeve. There's the black sleeve with this black wire. So there's 3 wires in this sleeve traveling along all the way to the end here. Now the wires come out. Look at their condition. Oh boy. Oh boy. See, down here, I mean, there's just it's pretty reasonable to think there's a risk of a short developing with, because the insulation's not going back on. It's only coming off over time. Holy smokes. Now all these red wires, they may all be at the same voltage, so it may not matter much, but I don't know offhand. There's that connection I failed to cut away too. Oh. Oh my gosh. So this was the end that I thought was the easy end. But way, way down, down, down there. I used to think of these cloth-covered wires as the crappy old wires, but now I don't. I think they are wonderful. The insulation could be cracked under these inside these cloth wires too, but I don't know. How do you know? Well, looking at it isn't going to help the situation any further. I don't think. I really am hesitant here. More coffee. Well, maybe now would be a good time to look into this other capacitor that's down under here and find out what I can about it. This is a really tough one to change out. Very, very difficult. The last thing I want to do is take out, this big coil here. That would no. If this were my own radio, I would take a different approach to this. It's not my radio, so I don't want to wreck it. That's really what it amounts to. Don't want to wreck it. Okay, let's look and find out what that capacitor is under there. Okay, it's under the big coils. So they aren't showing the big coils here. Okay, can't locate it that way. It's behind the tone control, kind of, so down in this area. Look, there's that thing that I saw earlier hanging in the radio. Coming out of the transformer. It's pretty mysterious as to what that actually is. I'm sure this has nothing to do with a capacitor or anything like that. It's not a gimmick. I don't know what it is. Maybe this transformer came with this extra wire they didn't want to do anything with, and this is how they handled it. Okay, getting back. Where is that capacitor? I don't. It's in this. Supposed to be in this area, somewhere. Let me look again. Okay, so it's really in the center of the radio, right in here. Oh, I don't see any capacitor here. Better landmark. A better. These are ground strips. This is a dividing panel right here. They're just showing a little tidbit of it. I think these are. I think this is the terminal coming from the capacitor up above. Well, I don't see any capacitor here. Am I blind? Yes, I am blind. Well, what do you do about that one? Okay, that was supposed to be something I could look into. Now, well, maybe it's in a different position. Maybe it's so one end is soldered to the other end is really on the switch. It's on the switch. Where's the switch? They don't show the switch in here. So the coils are here. One's here. The other one's here. And on the end is the switch. The switch is mounted right to the end of the coil. Well, I can look at this all day. I don't think it's going to show up at all. What about finding it on here? Well, I'll have to give it a go. so let me study the radio a little more. So I believe the capacitor I'm looking at, the one that's buried under the coil, is this one right here. And its job is to provide a signal ground on just this one coil. Now I notice there's a similar capacitor under the other coil, only it's a mica. It's a large, physically large mica capacitor. I suspect it's this one. But when I look at the size here, I don't understand that. Appears to say 10 microfarads. I doubt it. But that's what it looks like it says. Being a mica capacitor, I'm not so worried about it. Considering the condition of the capacitors, the paper and wax capacitors taken out of this radio, this one we can assume is very leaky. Range selector shown in short wave position. So this is not being used in short wave. Exactly how these switches work, the way they've shown them here, it's not readily obvious what's going on. To me, anyway. But it looks like this is only effective when this coil is in. If we look at the resistances here, it gives us an idea of the amount of windings. It's got the most windings in it by far, 45 ohms versus 7 ohms. This is probably the broadcast band coil. Now, what exactly is its purpose? So we have the antenna coming in. The antenna feed goes this way. When it gets here, it's forced through some things. Let's see, with this setting, short wave, it's forced through this coil and this one too. Could something be two trimmers involved. Of course, only this, the frequency band you're in, only one of these transformers will resonate. One of these coils will resonate. What's it? This is not a transformer as such. So this is laying coils up against the tuning capacitor, which is, I think, right here. So you're developing a resonant circuit between here and which coil or coils you've selected. It's a 3-bander, so we can just imagine these two things would snap up one. Now you'd be connected here through here. Seems kind of weird to me, but up you would go. You'd come out here and back. Flip it to AM. I assume that's what's happening here. So if this is not doing well, then the Q of this circuit is going to be, if this has an internal resistance, the Q of this circuit will be knocked down quite a bit. So the idea is you're bringing in a signal from the antenna. You're bringing in all the signals from the antenna. Everything under the sun is coming in on it. One of those frequencies will resonate against the coil and the capacitor. All the rest are going to find their way. They're going to be kind of weakened and dumped to ground. So you present on the grid here by far and large, by far and away, maybe it's the one signal you're after. It's not so sharp that it's only one station. It could be a group coming through here. Jim, you're starting to mutter. I think it's certainly worth changing this. The only reason I'm hesitant is because of its location. It's extremely difficult to do. Let's go back and look in the radio again. This is one of those videos where I do a lot of talking and don't do very much to the radio itself. So, capacitor in question is down under there. That's the solder spot. That's the tail of it there. Right there. Comes up, it's connected down here. I think I can probably cut this capacitor wire, pull the lead up, put in the new capacitor. I can probably manage to solder it down there. I don't want it, like I can't damage this coil. The other end, I'll have the lead wire pulled up to solder it. That's how I can do that one. It's a funny position for it. But look, there's another one under here. It's exactly the same position physically. It comes down. My gosh, there's two of them in here. There's one here and there's another one up here. So there's something special about having them physically located in that spot? Soldered to this spot of the chassis? Is that a significant thing? Probably not, but I don't want to find out by putting in a... You could put the capacitor in differently, solder it to a different spot on the chassis, find some other ground connection, make it easy, but it might have a consequence that's very hard to realize. That they put them where they put them for a good reason. Now, the reason could be very convenient during the construction of the radio. That could be all it is. They put in that capacitor before they put this coil in. I don't know how. I don't know. It's a pretty awkward place to put one. I think I have to try to get the replacement down in the same basic location. What? Haha, what was that? What was that? And then I got this guy. He looks easy. Oh my gosh. I don't know if I've got anything here I can even post on YouTube that's worth looking at. Just me whining. Just me whining. Okay. I'm going to stop again because I really don't know what to do here. Okay, just kind of for the sake of making some progress today, I'm going to go after that capacitor. See if I can even cut it. Whew, boy, I'm telling you. So I can't take this coil out. It's way too much risk involved in that because the switch is actually mounted, or the coil is mounted onto the switch here. There's no relief in sight here. Let me get my soldering iron for a second, because there's a situation here where I could start doing this and then find out I can't finish it, that it can't be done. So my soldering iron's not hot. So I'd have to solder something down there. That's not happening. That's just not happening. You'd have to cut the capacitor away, leave a lot of lead wire there, bend the lead wire over, drop the new capacitor down here, solder it, push the capacitor under up here, bring the lead up where I can catch the remaining lead from the original capacitor. First step is to cut the wire long down there. Oh my gosh. Oh my gosh. Yeah. So there's something I learned when I was working at the power company, a term called jackpot. It was a term the lineman used. I was not a lineman, I was in the engineering department. I was one of those office guys who didn't know anything. And the idea of the jackpot is you're a lineman and your life is at risk, so there's a lot of serious safety issues, falling, electrocution, and just being injured by heavy stuff. So a jackpot is a situation that you put yourself in, which then becomes very dangerous, or in fact leads inevitably to an injury. So an example would be you have a high voltage, you're up on a pole. Okay, picture yourself up on a pole. It could be in a bucket truck, or strapped onto the pole. In front of you is a set of live wires, and you need to reach something way over there. And so you reach over. You're reaching over. And you're over top of the wires that are live. Normally this wouldn't happen. Okay, linemen don't do this stuff. But this, for the sake of my example. So you're reaching over, but now you slip and you fall onto the wires. Now you might think I'm describing an accident that's not likely, but in fact there was a line woman working at my company who did exactly this. Leaned over some live wires. I don't know the details of it, but her hand support slipped and she fell onto the wires. And the result of that is a loss of an arm and a loss of one breast. So the jackpot situation is you've reached over and put yourself into a circumstance where if something goes wrong slightly, you're finished. This is kind of the situation here. There's all kinds of jackpots here. So for instance, I'm not going to get electrocuted. That's not what I'm talking about. What I'm talking about is ruining this radio, or putting it into a position where repairing it becomes an extraordinary effort. So an example would be cutting that capacitor out, finding out the capacitor is absolutely needed for the operation of the radio, which is kind of a given, and then being unable to replace it properly. Well, maybe you decide, well, I'm in a jackpot here. I can't get my soldering. I discovered after the fact I can't get my soldering iron in there, so I'll have to lift this coil out. Okay, so in the process of lifting the coil out, you break the switch. That's kind of how this could play out. That's why I'm doing nothing here. I've done nothing today except talk, because I don't know how else to keep myself out of trouble with this. You got a capacitor I can't get at. Oh my gosh. Well, again, for the sake of getting something done here today, I'll go after this capacitor because this one's right here. Let's do that. Then I can finish today saying I did something, instead of where I'm at right now. Which is really, I've become quite anxious about this. Okay, so we want to take this capacitor out. Let me get my clip lead here. If you are going to undertake these kinds of repairs in a radio like this, or any electronics, I really think it is a one thing at a time deal. If you try multiple things, like let's say I'm going to change 5 wires at once, which is kind of where this is heading. Changing 5 wires at once, and if I make 2 little mistakes, maybe I take the wires and do this with them by accident. I don't know. It could be almost impossible to find the problem. Of course, at the root of it, the problem would be me. It would be hard to find me. I kind of thought I was done with this radio. That's just being optimistic, I guess. Come on out of there. There he is. 0.01. What was this guy doing? Let's test him and then we'll find out what he was doing in the radio. Come on over here. So on a couple of videos over the last month, I've mentioned a couple times I have this telescope. I'm not going to talk about a telescope for a moment. And unfortunately, the weather conditions this summer have been terrible for using a telescope. The sky has been gray or smoky or something. It's pretty clear these days, though. And I have taken a lot of really interesting astronomical pictures, and I'd love to show, but I haven't done that yet. So at some point in some of these videos, I will plug in a few astronomical images that I've collected. So bottom line is, in case you've been wondering, because I know I've gotten a couple of emails from people, hey, what's happening with your telescope? It's going well. I'm having a great time with it. Okay, so watch the eye, 50 volts. Oh, it opened right up. Okay, about 3/4 open on a 150. And this is a 600 volts. So let's give it a 250. So he's still opening a slight amount. Now, a brand new good capacitor would pop right open all the way up to the top, 450 volts. So this guy's not as bad as some of the others. And if you notice, it's a different kind of capacitor. Made in the USA. Ericon. Okay, Ericon denser. Okay, so I'm going to replace that capacitor. I will actually done something today. Fantastic. Okay, I'll put the new one in because it looks real easy. Oh my gosh, I'm a little surprised about what I checked into what this capacitor is doing. So here it is on the diagram, right here. C31.01. So we'll look on the schematic now, and I'll show you what this is doing. C31. So it's near the output tube here. C31. Over here, output tube. That's C31. Oh my gosh, I thought I changed this right off the bat. So I think what's happening to me here is I've worked on so many similar radios in a row that I'm getting things mixed up in my head as to what I've done to which radio. Because this is usually one of the earliest things I go after, is the blocking capacitor for the output tube. The lucky thing, now that's interesting. The capacitor looked a little different than some of the others. It looks like it's probably a replacement. We could guess somebody went in and replaced this, and that would also explain why it's working better than the other capacitors. It's newer. It's not as old. And this is a target to be replaced in all these old radios. This is the grid blocking capacitor here. And I missed it. So the effect of this, if it were leaking enough, and I'm not sure it was, but if it was leaking enough, it could push the potential of this in a positive direction, make it less negative. Well, actually make this positive, because the cathode... I'm really confused. Too many radios in a row. I got to do something different for a while. Kind of erase my my confused memory here. I was going to say there's a cathode resistor here, but there isn't. That's right. This guy's getting his biasing from way down here. Right. Okay, well, I'm going to put the new one in here. It's not going to have much effect on the radio that we could ever detect. The capacitor that was in here was actually not in terrible shape. Not like new, but not like really old. 0.01. I'll put it in. Okay, I managed to put a capacitor in there. Now, I don't know what to do about this capacitor up in here, and as for the wires, now I'm thinking, for some of these wires, like this one would be a good example right here. Well, maybe not a good example. Very easy to replace this from here to here, that's what I would do. But in some cases, it might be better for me to cut one end and then slide a sleeve up over the wire. I'm trying to think of, trying to put as many tools in my toolbox before I go to work here. Or I may take an unnecessarily difficult approach to something and again get myself into the jackpot situation. Yeah, I'm not going to operate the radio today. It's not much use in doing that. I think I'm done. I think I'm done for today. So, got to kind of apologize for this video. Not much happened in it, but that's how it goes here. Trying to be just as smart as possible about this without making a big ugly mistake of some sort. Thanks a lot for watching. Don't know what I'm going to do in here tomorrow, and here in Canada we're having a holiday weekend, and I'll be tied up, so I won't be publishing any videos for probably 3, 4, maybe even 5 days from now. That's it. Thanks a lot for watching. See ya.